Welcome back. In this episode, we build a process for crafting void ingots, neutronium and echo fluid, lovingly baked in a giant heat chamber, which honestly feels more like baking than metallurgy. I also uncover a massive neutronium waste issue in our Stellarium setup and fix it just in time. This is Star Technology. Let's get into it. Since the last episode, I've been doing a lot of different upgrades around the place. Let's start off with this power situation. So as you can see, input and output is getting pretty high now. So we are actually regularly running out of power if we do a very large craft. So that's something we need to fix, and that's on the agenda for today. So I've also added a couple more of these storage monitors for the Melodium and the Stellarium. So that's our current state of things. Looking pretty healthy, actually. Obviously, Melodium's getting pretty good. Stellarium, that's not too bad. Neutronium's not too great, 223 buckets worth, but that's mostly because of the passive Stellarium, I think. Americium is looking healthier. Now, that's less than you probably saw in the last episode, but this actually did get down to 0 because we were eventually draining it. So I've added a few more, and that is now slowly increasing. So that is good news. So what I ended up doing was adding one extra Stellarium electric blast furnace just back here. So I've actually got 2 of them. So that's how I managed to get that amount, and that's also why we're draining so much neutronium. As a consequence, I had to move the mixer because that was obviously on here. I didn't want to build another one. So I've built this over here. So that's just the mixing setup. What I might do is actually move some of the mixers over here in the line, because I think that might work. Even though this still says Naquadah, this is not being used for Naquadah anymore. I've actually migrated it to the second rotary hearth furnace because I discovered a way to make this produce Naquadah a lot faster. I've added 2 UHV hatches here. So UHV 4 amp energy hatch and a UHV energy hatch. And that has had the effect of taking up to UEV as the max recipe tier as well as the power tier. I did some testing and I found I could actually have a higher level of parallel if I managed to raise the recipe tier. Now, this is actually capable of producing quite a lot of Naquadah in one go. I'm still a bit hazy on exactly how all that parallel stuff works and in terms of power consumption. It's a tricky thing. I need to do a deep dive at some point. Oh, there you go. It's fired up. Every 40 seconds, it should spit out an entire stack of Naquadah. There we go. It only flashed up very briefly, but that was one entire stack. So that is a lot faster than with the electric blast furnaces before. In fact, it's actually creating quite a backlog with the vacuum freezer. The vacuum freezer doesn't process these very quickly at all. So as you can see, this actually builds up. The Naquadah ingots are very slow compared to the others. I might need to do a follow-up video at some point about how these parallel control hatches work. I've been messing around with them and I think I've got a little bit of a better idea, but it's still not fully crystallized in my mind, I guess. The next big thing, this facility here. So this is a giant warehouse that I've been building. This is where we're going to do all our Stargate stuff. We need a large area, created a scaffolding here just to make sure that the buildings would fit. This is the tallest of the machines we're going to have to build in here. It's basically the same sort of footprint as the rotary hearth furnace, I believe. And so I just wanted to make sure it fit. I also wanted to use the roof as a place for more solar panels because we are running low on power, as I mentioned earlier. And I didn't want to just have like large flat areas of solar panels. I actually wanted to use the roof area. So that should effectively double our power. I did a lot of tweaking and trying to figure out how to design this so it looked kind of cool. I had this idea of this big open area with all these supporting structures and things. This is polytetrafluoroethylene blocks as a structure, and then obviously steel here, and then the walls of the warehouse, which I've done in this sort of a crinkly kind of pattern here with copycat panels. That's actually maraging steel because I liked the color. So this is where we're going to build some of our stuff today. So this is where we're at. Building the Drac Ion runic wave generator should be possible now, which means we can probably build that shrub laser and get the runic circuitry assembly station. What I might do is actually queue that up because that will take a little while, and then move on to this because we need to get these raw void ingots happening as soon as we can. And that's a little bit of a process. So let's see how we're going with this Dracon thing. No, we're just slightly short on Americium. This was a problem I had earlier. This is one of the reasons why I had to upgrade it. But everything else is there except for that Americium. We only need 10 more buckets. That shouldn't be too long. While we're waiting, I guess what I can do is talk about, well, start on the next bit. We want to get raw void ingots. Actually, I mean, this whole path here leads to making Stargate rods, which are crazy, absolutely crazy. Using a super pressure heat chamber, taking a crude Stargate rod, 120 seconds, That's not too bad. How do you make a crude Stargate rod? This. So a long void rod, bunch of weapons grade Naquadah, which we don't have yet, neutronium foil, like 2 stacks of neutronium foil. That's half a stack of ingots, I guess. Kind of slow, but not too bad. The problem we're going to have is actually how many of those we need to make these chevron blocks, which we're going to need a few, and each of them takes 56 Stargate rods, as well as other things. So that's kind of a lot. So we should get onto this pretty soon. If we go back through these various steps, you need void ingots, heat chambers and stuff, but it all starts with these echo shards, which we've had for quite a while. Now, how are we doing for echo shards? Not a problem at all, 1.3 million. In an extractor, you get 144 millibuckets of echo fluid. It takes 600 seconds, that's 10 minutes at LUV power. So even if we crank that up to UV, that's 150 seconds. I'm going to build a large block that we can parallel control hatches and overclock the heck out of. So we'll see how that goes. Once we have that echo fluid, the scary thing is this, the raw void ingot, in a fluid solidifier with a neutronium ingot and some echo fluid. That's pretty slow. And getting to grips with that, once we have the raw void ingot, we need to run it through something called a heat chamber, because that is the only machine that can turn it into a hot void ingot. You can't use this in an electric blast furnace or a hearth furnace or anything like that. Yeah, it's a custom machine for this one particular conversion. It's very slow, so that's not great, but we'll see how we manage that once we've overclocked it a little bit. This is the recipe in the assembly line. Not too bad for the controller block. So it's pretty big, similar kind of shape to the rotary hearth furnace. This is the scary thing for me, 64 neutronium frames. 475 of these thermal fluctuation-proof Endgame casings, 92 of these high-temperature spotting casings, that's not too bad. Tungsten steel, copper nickel, that's fine. Extreme, yeah. So most of these are fine. We haven't touched those, and neutronium frames are just a bit scary. So that's the plan ahead. That's what I want to achieve this episode. I want to get this working, get this crafted, maybe get the runic circuitry assembly station installed and starting to do stuff, and we'll take it from there. In the intervening time, the americium we have has increased to a high enough level, so now we can actually queue this up. So I'll do that now, get that started. Well, I've got all the components. What we're going to do is we're going to build a large extraction machine here, and then over here we're going to build a large solidification array. So we're going to do that, put the large extraction machine there. I guess we'll just build it by hand. It's not that complicated. That, like that. Auto maintenance hatch and a parallel control hatch. Almost happy, we just need some power. We need some hatches and things in here, obviously. So what I'm planning to do is the output from this, which will be a liquid, will go into this machine directly through a pipe rather than through the ME system. So I'll put the output here, and I'll put the input bus here. Okay, so we've got some echo shards. Let's put them into here and see if this works. Well, it's taken them. That appears to be extracting. So in 150 seconds, we'll get that liquid come out. Well, let that go. Let's build the next machine, which is the solidification array. Looks like this. What's inside? Oh yeah, cool. Let's get to building. And we'll do the same thing we usually do. Place those two there. Now let's hook up some power. It looks like it's powered up. Now we need a input hatch, probably here. And we'll just run a pipe. Why did that not auto eject from there? Let's try picking it up. Yeah, there we go. When you attach a pipe to something, sometimes it doesn't realize it's attached. So that's into the input hatch now. Maybe here, we'll put our input bus. So the output can be up here, I guess. So we want a neutronium ingot in there. Grab one of those just to test it. There we go. That is working. So we haven't set up the parallel on this, so we'll do that for subsequent ones. And that should give us the raw void ingot. Cool. No fanfare? No. Okay, hang on. Probably need to click a few requests. So let's click that. There we go. And now I've got the raw void ingot. So once you have the raw void ingot, you need to cook it in a heat chamber. So that's the next part of this build. Guess I'll build that somewhere here. How's our build going with the runic thing? A lot of components for that. I did notice that the blast chiller was not coping with it very well. There's a lot of backup in here somewhere. There you go. That's pretty full, and so is that. So it's doing its best with what it can. It's like overclocked as much as it can be. We'll see how that pans out. That'll take a little while. But what we need to do next is this heat chamber. Better encode the pattern for that heat chamber, because I haven't done that yet. And we have everything except the double tritanium plate and the liquid niobium nitride. Okay, so that's a new ingot we've got to do. Hopefully that's not too difficult. Ah, that's pretty low level. Okay, that's not a drama at all. I'll do that offline. I'll set that up and come back. Okay, well, I've encoded all the parts for that. This is now installed in the assembly line, so we should be able to request one. I did notice that it does take quite a long time to make, even at ZPM. So once this is queued up, it's going to take a little while before we get it. Something that was a little bit of an interesting quirk that I didn't expect was this niobium nitride. So I was expecting it to just be probably just a recipe in a mixer or something like that, but it's actually a recipe in a chemical reactor to react the niobium dust with nitrogen gas. So can we actually request this now? Got a lot going on with that Drac ion runic wave generator, so I wouldn't be surprised if this does take a long time. Well, at least we can request it. What are all the components we're going to need for this heat chamber? Thermal fluctuation proof Enderium casing. Okay, don't have that. Just Enderium. Okay. Let's request one of those. Where is it? Is this going to work? Apparently. Okay, that's done. So how many of those are we going to need? 475. What else are we going to need? There's neutronium frames. Okay, nothing else there is too complicated. Neutronium frames are going to use a lot of neutronium, but they're not actually that complicated. Yes, it's a typical frame recipe. Let's make 63 of those. So it's not going to use too much neutronium. Let's get that started. I'll go through and make all the others now, and then we'll come back and build a heat chamber, I guess. I've gathered most of the components for this heat chamber stashed over here. There's a few that are still being made. I noticed an interesting problem. I was watching the production of this. It had gotten stuck on the liquid vanadium gallium, and I couldn't figure out why. And then I realized the vanadium gallium process I had was extremely slow. This is how I make how I used to make my vanadium gallium. And as you can see, this is absolutely stuffed with vanadium and gallium dust. It's producing a vanadium gallium ingot or two every 18 ticks, which is too slow. Because of the demands of the vanadium gallium, it was just stalling everything. Back, say, 10 episodes ago, this was plenty fast. But now, with the sort of throughput we need, it is not enough. So what I did was I realized, well, the hearth furnace can do it. In contrast, if I tell this thing to make 64, that's it. It just made the 64. Yeah, the lesson to be learnt here, I think, is that it pays to just keep an eye on your crafts and just upgrade your infrastructure and your recipes as time goes on. Like, don't just leave them as they are. Have been doing that, but I must have missed this one. I didn't realize just how slow it was and how much we needed. Rather than sort of mess with all this and worry about all these gases that are left there, I'm just going to let this run through, even though there is a bit of a backlog behind it. But yeah, at least the craft that I'm worried about, which is that runic ion generator thing, is actually proceeding. So that is good. But yeah, I thought I'd share that. So I was checking in on the crafting of the Drac ion runic wave generator, and I noticed that it installed. All the components are in this assembly line, but it's not making it. So first thought was, is it the right tier? It turns out it is, because it just requires UV. And then I checked all the the solid ingredients, because that's normally a problem if there's stuff left behind. And then I checked this, and I was like, okay, that's a little bit odd that they're all completely full. Checked the numbers in the actual craft, And it turns out the hatch is too small. This one requires 63 buckets, that's 54, that's 32. So I'm gonna have to do a little upgrade. I don't want to lose the resources, so I'm just gonna extract that and pop in the new one, like that. And then I'll just bucket these across. There we go. It's gonna take 800 seconds, so I'll come back after that. So I've just had two pieces of news reach me, one which is good and one which is bad. The good news is we now have the Drac Ion Runic Wave Generator. So that's very exciting. That took a long time to craft, but we have now achieved that. The Shrub Laser Beam Concentrator and Emitter Capable Stellarium Casing. How do we make that? Oh, we can encode that recipe and just get it to craft. Maybe I'll do that, and then I'll tell you the bad news. I don't want to accidentally craft another runic generator. It should just use the one that's there. Excellent. So the bad news is I have goofed with this Stellarium setup. So as I mentioned at the start of this episode, we built this and then I expanded to build a second one. 4 electric blast furnaces all churning away. I have discovered something with the help of Truly No, one of the creators of the mod pack. I am using a very inefficient recipe for making Stellarium. I've been using the Stellarium dust and then cooking that in the electric blast furnace. As we saw last episode, this requires 12 buckets of liquid neutronium. Now, one thing I didn't do, mostly because I was lazy and because the alloy blast smelters I've built are all integrated, so I didn't even consider trying to upgrade these because I'd have to upgrade them all at the same time and it was just a bit of a mess. Didn't even think maybe I could build a whole new one somewhere else. Anyway, the molten Stellarium recipe, which, we'd expect it to be slightly faster, it only uses 12 neutronium dust. So 1 neutronium dust is made from 1 neutronium ingot, which you can create from 144 millibuckets of liquid neutronium. Now, in the other recipe, we're using an entire bucket, so it's 7 times more, which is absolutely crazy. No wonder I've been going through my stock so quickly. So I need to fix this up. So that's what I'm doing. Because of this machine here, this mixer, it had already created a bunch of Stellarium dust. So there's no sense in not cooking that because it's already been created. Oh, hang on a sec. Can I electrolyze it or centrifuge it? No. It doesn't get me back the whole 12 buckets. I might as well just run this out, switch this machine off. I've removed the neutronium liquid from here. I'll decommission this and I'll build another alloy blast melter out here somewhere that's dedicated to creating Stellarium. That's a little bit annoying because we've already created quite a lot of Stellarium. So we've got a lot of neutronium that's been gobbled up. That's what happens sometimes. So that's how much neutronium, that's how much Stellarium. That's a lot of neutronium that's gone into that, unfortunately. Oh well, you live and learn. And it also appears as though this Shrub Laser Beam Concentrator and Emitter Capable Stellarium casing failing to craft, and I've just figured out why. It's that same problem that I had one time in an earlier episode. That looks like a 1 to me, but it's actually a 7, as you can see when you mouse over it. So I've put this into the wrong one. I guess I'll just change this to 7 temporarily. There we go. All right, cool. Let's fix that. And now I guess we need to start thinking about this. Even though I haven't done all this yet, I need to build the heat chamber. But I might as well encode this recipe and get this crafting because this is a long craft. That's what I'm noticing with these machines. So we're used to things that take, half a minute, maybe a minute to craft. Now we're talking 15 minutes for some of the bigger ones. Let's encode this. Do I in fact have everything there? I do. That number's probably wrong. Yep, that should be 4. Let's encode that. Put this into here. All right, let's craft one of those. All looking good. That Stellarium dust is being used up, and I just need to find a place to make the Stellarium. I could put it here. All right, what's the shape of it? Okay, cool. Boom. Neutronium, Melodium, Dragon Steel. So we want program circuit 13, and then we want some Krypton as well. There we go. Okay, the electric blast furnaces have finished off all the Stellarium dust that we had left over, so that is all good. This infrastructure actually turns out is still useful though. Something we're going to need soon is called weapons grade Naquadah. And as it turned out, there is actually no molten recipe for weapons grade Naquadah. You have to make it in an electric blast furnace. Obviously, this setup that we've got here is actually going to work really well because this is UV voltage mixer set up already and 2 electric blast furnaces. So we'll reuse that for the weapons grade Naquadah. With that in mind, I decided one of these for Stellarium wasn't enough, so I've got 3. It takes about 75 seconds to produce one single ingot. If we remember over there, it was 101, but there was 4 of them. So I think this is about the same speed because we produce one every 25 seconds and then that over there was about one every 25 seconds as well. All right, well, we need to get onto this over here, the heat chamber. So this is what it looks like. It's a pretty tall block. Like I said, it's about the same size as the hearth furnace. It's got an interesting quirk that the top isn't quite circular like the other layers are. Like you can see there's actually some blocks missing. So that's something I'm going to need to be keeping aware of. It's got an interesting structure because the only place you can place hatches is on this front face here. Let's get to it. So we'll start with these guys. I might do something a bit different and actually use this line tool. So let's do this. All right, that's the first layer. Let's put the controller block in, a few more of those high temperature casings. Now we're going to need loads of tungsten steel parts. So the rough shape, it's very similar to the hearth furnace. So it's got like a cross shape. So we'll start with the firebox casings. Extreme intake casing, tungsten steel pipe casings. Basically we mirror what we did on the other side, 2 of those. And then there's like a gap here, do this shape. 2 of those in there. And now we have neutronium frames that are going up in these corners. 1, 2, 3, 4, 5. 2, 3, 4, 5. So now we just basically repeat this, but with a small change. Now the difference here is the pipe casings actually go all the way to the edges, like that. And then we just rinse and repeat until we get up to this level. So let's do that. Cool, all right. So let's build this circular shape again, do it with lines. I'm basically just copying what's directly below. Now surprisingly, this entire section here is actually filled in. There's no pipes that actually go through it, which is a little bit odd, but that's how it's built. So for this level, we want this sort of structure. And now we want a lot of coils, starting from the middle, make a cross, put some of these at the ends, and then finish it like this. Now we just need to do 2 more layers. Bring out the trusty line tool again. It's much easier when you're following the template of the level below. And once again, fill that in. Final section is just a copy of this. Cool. I'm just going to fill the whole thing and then cut the part that we don't need. I think that would be easier. Slightly short. But that's all right. We need to cut some out. Put an auto maintenance hatch here. We'll have to run power on the front, so I might just put it to the side here. Like that. It's completed. There you go. There's a heat chamber. That looks kind of cool. Let's hook up some power to this thing, and then see if we can't actually start using it. So I can just put that straight onto here like that. Soft mallet, flux point. Okay, that's got power. So it's just as simple as putting the raw void ingot in there and waiting a long time. So I guess we just want an input and an output. Doesn't get much simpler than that. Input bus there and an output bus there. Grab an interface, pop that on there. So that should kick off shortly because that will be requesting those. There we go. How are we going? Oh, 3 seconds. That's very quick. I didn't expect this to be so fast. I thought this was going to be slow. Okay, so let's go over here and hook this up so that it can actually cool them. Wonder if the process of cooling them is going to be slow. No, that looks pretty quick. Void ingots. Nice. Now that we've got the Void Ingots sorted out, we should probably get onto this weapons grade Naquadah. I'll do what I said I was going to do. I'll set up this system here. Weapons grade Naquadah is made in a UV mixer, 60 seconds, from pure netherite dust, neutronium dust, liquid Naquadah, and fluorine gas. And that doesn't look too complicated. So let's have a look what we've got here. We've got an export bus and an interface. Okay, that's perfect. So what I'll do is I'll put a capacity card in here. Liquid Naquadah and the fluorine gas. And that will also need a crafting card for the liquid Naquadah. And then now I just need the two dusts, which is pure netherite dust and neutronium dust. So we'll do the same thing we usually do here. Pure netherite and neutronium. Crafting card's already there. I think I might already have a... Yeah, it does have a rubber arm in there, so I just need to change this and drag those two in. Keep exact. I'm not sure why they're not showing up. But they are there. Good to go. So I should be able to turn this on. And there we go. Nice and simple. Let's clear that storage bus and change it to the weapons grade Naquadah dust. Just change this to bring in the weapons grade Naquadah, because that's all it is. We're using nitrogen instead of some of those exotic gases like neon and krypton and all that. Just change this to nitrogen. Then we'll empty this. We'll set this up to, instead of being Stellarium, weapon grade Naquadah dust. And there we go. 50 seconds, so 1 every 25, not too bad. And then the final part of the puzzle is telling this guy that it can cool those ingots. I think what it means now is we can produce all of the materials we need for the endgame. There's no new things we need, because I think this covers us for everything. Like this top row is everything. Obviously recipes we have to set up, and things like this guy here, the Stargate component assembly, has some pretty crazy blocks in it. But I feel like they're all ones that we now produce. I think we're getting there. Well, I think that's just about all the time I have for this episode. So we managed to get those Void Ingots happening, which is pretty exciting. Also the weapons grade Naquadah, 2 crucial materials we're going to need for the Stargate rods. I'm hoping I can probably get onto the construction of those pretty soon in the next episode. It's going to take a long time. We're going to need a lot of them. I just also wanted to quickly mention that I've created a Discord server. So if you want to join and discuss modded Minecraft, then the details are in the description. So thanks for watching and cheers.